Daniel, thank you so much for coming to the CADFEM conference on optics and photonics. It was great to have you here. For those who missed your talk, could you just give a brief overview of it?
Absolutely. So my pleasure being here. It's an absolutely very well-arranged conference, and I'm learning a lot listening on all the other talks as well. My talk was about Flexenable technology in liquid crystal optical elements and how they're used to, especially in augmented reality applications, for enhancing features that are difficult, and especially specifically about modeling and moving forward with dimming technology as well as liquid crystal optical lenses technology.
Yeah. And how about for the tunable lenses to move the image distance?
Yeah, that's also something that we've gotten quite some way, and we're making lenses that behave really well on axis, making diffraction limited imaging on axis, but off axis we're still improving the performance as it drops off. Any optical element drops off axis, but it's also quite noticeable for liquid crystal lenses, and something that we've been working on with there is to create new kind of drive schemes and electrode profiles that improve that. Has been really helpful in that way, both from starting a design perspective as well as, of course, confirming that the design is up to par.
And so you mentioned about optimizing this, like the drive scheme. I guess you mean the electrode layout. Can you maybe talk about what exactly it is that you're doing to optimize that for to improve the off-axis performance?
Sure. So liquid crystals in general are these elongated molecules, and by design they're asymmetric. And if you go to make a liquid crystal lens with radially symmetric voltage profile to create this gradient index profile that enables lensing, you're left with something that's non-symmetric, which will then image. Because
of the director profile of the
direction
of the
exactly.
The
So
liquid crystals,
if a liquid crystal molecule is like this, then light coming in like that and like that will perceive very different.
Which would be different on the two sides of the lens
exactly.
for the off-axis fields. Yeah.
So in order to get around that, you can stack multiple cells, so basically having a symmetric system in 2 layers. But what we have found is that you can get the same kind of feature in a single layer if you just tweak the molecular orientations in different areas of the lens.
And I guess what's the challenge, or what's the problem with going with 2 stacks?
So, as with anything, you want to reduce complexity. You want to reduce the number of layers for cost reasons, and as well for haze. You do introduce a certain level of haze for any optical component in the stack, and in a device like an AR headset, where we as a tier 1 supplier will only be allowed a part of the haze budget, you want to come in as low as possible on that regard.
Yeah, and I can imagine they are tight on tolerances, want to push that all the way down.
Yeah.
Well, it sounds challenging, but fun. Can you talk about what exactly you do to the electrode configurations that makes the improvement for off-axis performance?
So we've set up a design pipeline or optimization pipeline that relies on basically simulating the optical performance at different angles, and we then optimize the electrode structure in such a way to get basically a symmetric profile from this anisotropic liquid crystal environment. And
symmetric in terms of the optical performance as opposed to in terms of the electrode configuration.
Yeah, exactly. So what we're left with, optimizing for that symmetric optical lens profile, we're left with something that's oval in shape in terms of the electrodes, based off of just the physics of those anisotropic molecules and how they orient.
Getting a bit more into the technical details, can you give an overview of what you've used ZMAX for instance?
Sure, yeah. I mean, ZMAX is definitely our simulation staple, my go-to for any evaluation. We're working with a broad range of different, both technical programs in the LC optics, but also just using it as a tool for experimental design. I recently used it to design the imaging part of an interferometer. That's now a critical piece of equipment for evaluating our optical performance of lenses and so on. We're using it for imaging optics, for illumination optics, to quickly iterate to optimize designs, both for our applications as well as kind of enabling technologies in our lab.
Mm. And have features like the lens catalog, for instance, helped you get like benchtop experiments set up quicker?
Absolutely.
Because then you're using off-the-shelf components inherently in your design?
Yeah, generally when setting up, I think, experimental designs which are not going to be scaled up, there's definitely an impetus to use off-the-shelf optics, and then that's been critical to streamline that.
Any other features that you've used in ZMAX that have been particularly helpful for this project?
So certainly the physical optical propagation toolbox has been very useful to get from. We often have in liquid crystal optics, especially the kind of approach that we're using, we have Fresnel resets, which are kind of difficult to map in other other features in ZMAX. So the physical optical propagation has really been useful to get that implemented in a stable fashion.
Yeah. Yeah, it's kind of interesting because usually I think one thinks of ZMAX as a ray tracer, which of course it is at its core, but having the ability to propagate a complex field really opens you up to being able to capture other effects like diffraction accurately in a system. So
yeah,
it's quite a powerful feature set within it.
Yeah, certainly. Liquid crystal optics is strange in that way because it's kind of a step away from the kind of optical simulation where you get most of your optical effect at the boundary, but rather something that's more akin to grin lenses where you're getting a gradient index profile throughout the cell.
And moving forward, what do you see as the keys to unlocking greater utility out of ZMAX?
Oh, that's a good question. I mean, I think one thing that liquid crystal optics in general would benefit very, very much from is the ability to incorporate from a electric field simulation in an anisotropic media or dielectric media that sets up a electric field profile that the liquid crystal molecules align to is something known as a director profile modeling system, where if that capability was enabled in ZMAX, I think that would open up a breadth of different potential in this field.
I think in ZMAX, it would be strange for that to exist in ZMAX itself, just the very different physics. But certainly we can, within ZMAX, within the birefringent surfaces, we can incorporate a director profile that's generated externally, so potentially with other ANSYS products, or it can be anything as long as we format
I think
it. That's something we can work together towards.
What's been talked through today is just the breadth of interoperability between the platforms that ANSYS offers, and in that case, I'm sure that there will be a path forward to integrating that kind of optical system.
Yeah, and certainly when we talk about different products, one of the things that really makes them cohesive is the existence of APIs. For instance, the Python API for ZMAX, which can handle a lot of the handshaking between different software, enables to make kind of custom solutions using the existing simulation tools that ANSYS provides. So I think that's something fun for us to explore as well, and it can definitely couple with other Python programs or other languages as well that you might have as part of your work.
Definitely.
Well, thanks for having this conversation with me here, Daniel, and it's been an absolute pleasure having you at the CADFEM conference on optics and photonics here in Munich. We really enjoyed your presentation, and we hope you'll join us again for these events in the future.
Likewise, I've had a blast, and as I said in the beginning, I've learned so much. It's fascinating to see the breadth of problems that CADFEM and the ANSYS packages that you offer can help solve.
And I think it's just so powerful to get users all in the same room so they can have water cooler conversations about how they're getting the most out of the tools and what else they can explore with them.
Yeah, definitely. I've had very fruitful conversations with people in a variety of fields that's sparked kind of thoughts that I will look into getting back to Cambridge.
Great. Well, thank you very much. It's a pleasure.